Hello students. Today we'll do the data stream analysis lab. So this is useful for the B students who are having the subject BDA, in which they have a lab on data stream analysis. So what you could do is you could visit this link bit.ly TCO student. So if you are a big data analytics students in B, you should find this folder, and there are many useful resources over here. So let's see, and one of them is your lab instructions. So you see the lab section, and though there are individual files for streaming data analysis, it's more detailed instructions consisting the installation steps and so forth. So we don't want to get involved on how to install, but how to perform the lab. So we'll directly go, in case if you want to know how to install, then refer this particular document on 09_ streaming data analysis. But if you just want to go ahead with my machine, so the machines are all, what is this? How come this name has come up? Somebody has put up a name over here. Okay, so in this I have this is a file format, and here you will find the exact instructions that you need to execute for data stream analysis. So this is, here you can see this is lab number 9. So let me zoom this up. Okay, so you would need a machine which has everything installed. So that is the first thing. If you want to have the machines, so all the machines are available on my GitHub site. The link for that also should be given in the page. So here you see this is a link, this is a GitHub link where the links for all the machines are there. It is labs, and here you'll see instructions, machine images for bachelor. So different machines are available for the different labs, which is kept ready for you to install, import it inside the virtual box and start the lab immediately without any installation. So this is the link. So I'll just show you once. So when you visit this link, you should get all these files. So these are all files. It is one machine but split into multiple files, because each file is like 1000 MB, and like total you see it's almost like a lot of files and lot of it's a big machine. So you need to stitch this into a single machine.ova file, and for that you can use you could use 7-zip. Okay, I don't know whether I've got any files here. So just to see an example how to do it, so let's say data stream analysis. So here you see I've got a single OVA file which is like 10 GB, but when you download, you need to unzip this like this. Only this OVA file should be there, and then when these files exist in your directory, these are the only files which should exist, which once you click on one of them like .001 and right click, 7-zip, open archive, and after that you need to go back one folder. So you see I'm going back one folder so that I can see everything. Yeah, so sorry, here you need to click one of the files and not there. So, and once you right click over here, you will have the option of combine files. So once you combine the files, it will ask you for the folder where you want the file to be saved. So let me see if I can create a new folder, like a test folder. So let me say new folder test, right? And it will save to the test all these files. It will stitch into one single file. So we see all the files are getting stitched, and I don't want to stitch everything right now. It might take time, or I might wait. How many seconds are there? 4 minutes. So it will take 4 minutes. So let me see if this file is there over here. So you see this file is getting created over here, a single file. So I don't want to continue more on this. I just want to pause and cancel this process. Yes, I want to cancel this process. So that's how you, if you want the machine, that's how you stitch it into a single file. And once you have that kind of machine, so you'll get something like this file. So you can go into VirtualBox and you can simply import this machine over here. File, import appliance, and then go ahead and select that machine OVA file, the single stitched OVA file. So let's say let me do this, and here we have data stream. So once you do this and click next, automatically it's setting up. You need 4 GB minimum, so it's saving in this particular folder, and then you go ahead and click and finish this, and it will import. So I don't want to import this entire thing, so let me see if I can stop this. Okay, so I've stopped this. Already one particular machine has been created like this. So the moment that finishes, you will have one more entry over here. So let's go ahead with the lab quickly on data stream analysis. That is, so now you see as soon as you install the machine and now you start, I have a ready-made machine all ready to start. So let this machine start. Let's click switch, and in the meanwhile, as the machine starts, we'll go through the instructions. So what are the instructions and where are the instructions? The instructions are here, right? So it's the 9th lab in this journal. So let me go there. Where are the instructions? Okay. So this lab says aim is to perform data stream analysis. The VirtualBox already has Hadoop, Hive, Flume, and RStudio. So before we get into the lab, you need to understand the basic concepts, right? So let's see, we can do that with a diagram. So data streaming basically means, a data that is streaming, like a river is streaming, right? So something like a river is flowing, and something, it continuously flows in one direction. So in the same way, data keeps flowing in one direction, and we want to make sure we catch that data and we analyze the data. So we would like, all over the world, there is some news, and you want to or maybe you just want to track all the comments, let's say coming from Instagram or something, streaming from Instagram and then from FB and all these sources. The data is coming in, and the big data as a big data, which means in bigger volume, in greater velocity, in variety and so forth. So how do we capture this data, streaming data, real-time streaming data? So as per the lab, you need to use Flume. So instead of Flume in the market, we have Kafka, and Flink. So if you're going for a job, then definitely you should have skills of Kafka and Flink, at least Kafka. So in this lab, we have Flume. So this is divided into 3 parts: source, channel, and sink. So all the data is first put in the source location. So here is where all your files will go. Then as the Flume is running, it will put it in the channel and ultimately into the sink. So this is the basic architecture of Flume, how Flume works. So what you need to know, you can have multiple sources. So like let's say source 1, source 2, like one is, let's say you have Instagram comments, let's say you have Facebook comments, and you can put it into different source, right? So you can say Instagram source, you can name the source Instagram source, and this is a Facebook source. So all the data, so you can have multiple source, and of course you can have multiple channels, or you can have one channel. So both of them go to one channel, right? And you can put it in a single sink or multiple sink. Just there are multiple sources, you can have multiple channels and multiple sinks. So let's say we put it in online comments sink, something like that. So this process keeps going on. Anytime there is something in the source, so you have to create a link between Instagram and Instagram source, Facebook and Facebook source. So as soon as something happens over here, this may be tied to multiple accounts or single account. So the data will continuously come in through this direction as a real-time data stream. So that is what one of the part of the lab is to perform a data stream operation. But in this lab, we are also using we want to see this data, we want to analyze this data. So what we do, we use RStudio for that. So RStudio, whatever data is coming in the sink will ultimately has to reach RStudio. So here I want to see all the records. I want to see, select count star of, from comment, something like that. I should be able to see all the records, or I should be analyze, or find out the hate comments, so that you can take action on that. So there are various analysis that you can do in RStudio, and you can use graphs over here, like you draw a graph in RStudio, right? So something like let's say you have a graph, a line graph or something. But the thing is how the data will come from sink to RStudio, and this is where we use one of the big data technology, because the data is very huge. You need to understand that, and that is why we use Hadoop system. So the Hadoop system, we use SDFS and of course MapReduce to collect all the data, and if there is any query, then the MapReduce will execute it. But the thing is, we want to execute query using SQL statements. So Hadoop is not a database per se; it is a file system. So how do we, make a SQL query and convert it into Hadoop MapReduce task? We can use Hive over here. So this is where you can use Hive. So in Hive, you can fire your SQL commands, and Hive runs over Hadoop. So whatever is inside the Hadoop, it can take all the data, convert it into SQL results, and give it to you in RStudio. So this is the architecture. So that's why we need this force, all this software. Flume we need Hadoop, we need Hive, we need RStudio. So, and we need some data source. So in our application, in our lab, we are going to use a chatbot data set, which is already downloaded, so that we don't have to link anywhere. So what we will be doing, we'll be taking data from the data set and trying to simulate as if somebody commented and put it in the source over here. As soon as I put it in the source over here, right, let's say I put it over here, so some chatting is going on. This has to go into the sink automatically. The Hadoop should be linked to the sink, and Hive should be linked to the Hadoop database or Hadoop file system, and RStudio should be should connect to Hive to make the queries. So analysis will happen in the front end over here, right? So analysis will happen over here. Data streaming is happening over here, and your big data management, storage and query and processing is happening in Hadoop and Hive. So now that we have understood this is the architecture, we are ready to execute a lab. So as you know that before we start Flume, definitely Hadoop is at the heart of the system where the actual data lies. So Hadoop has to start first. Then we have to make sure Hive is in action. Hive is running. Then we have to make sure Flume is running. Then we have to put the data over here, and ultimately in RStudio we verify. So that's how we'll perform data stream analysis over here. So you see start Hadoop. So we go and say start dash all.sh, right? So let's see. So the machine has started. So the password for all these machines are TCOE student is a username and TCOE 2024 hash. Okay, so that's the password in case if you need the password of the machine. So just let me type the password for accessing this machine is TCOE student is the username, right, and TCOE 2024 hash is the password in case if you need it. So let's go ahead and start the terminal. Hold on. Okay, let's continue. So there was a problem in the volume. My mic was switched off, and so there may be some issues with the volume. Just increase the volume and hear it. Okay, so let's go ahead and start Hadoop. That's where we were, right? Okay, so this is the terminal. So let's start the terminal. So before we start the terminal, so I'm clearing the screen by using the clear command, and I'm just looking at the folders. Okay, so here you see there's Hadoop 3.4.0 installed. We have Hive installed. right? And we have some data stream analysis folder, right? And we have Apache Flume folder also over here. So we have, everything installed. So I'll clear the screen and we start Hadoop saying start -all.sh. So this should start your Hadoop. So let's wait for Hadoop to start. In the meantime, let's go ahead and see what are my other commands. So immediately after that command, Hive. So Hive cannot start, Hive needs Hadoop. So that's why we need to wait for Hadoop to start. So here you see the name node is starting data node. So name node and data nodes are part of your HDFS. Name node is your master node, data node is your slave node of HDFS, right? And then you have a secondary name node, which is a backup of the name node. So if something happens to the primary name node, the secondary name node will take over. Okay, so let's hold on. So here you see resource manager and your node managers are starting up. This is part of your yarn. So yarn helps you in managing the nodes and job scheduling, right? So everything is started. If you want to know what all processes have started, you can type JPS and see if everything is running. So you see resource manager is running, secondary name node is running, node manager, data node and name node. So yarn and HDFS both are running, which means your map reduce also will run. So now that we have done this command, we can go with the Hive command, Hive space. So we are starting Hive now. So what is the command? So command is Hive space. So now here it says, actually it's -- service. So let's go ahead and do that. Hive space -- service space Hive server 2 space ampersand. So this should starting in this is started with the process ID 3873, and we are going to wait for Hive to start. So we are going to wait for 2 session entries shown up on the display screen over here. The moment it shows 2 of them, we know that Hive has started. So it's starting Hive server 2. So we still wait. The session is not yet started. So let's hold on. So session ID 1 has shown up. Now we need to wait for another session ID, and then we can move ahead with the next step. So let's hold on, and in the meantime we'll go back and see what is the next command. So next command says use beeline. So beeline is like your, you can connect to Hive and fire your SQL queries against a Hive if you want to know, what all database has been created. So in our case, what we are doing is we are creating a database called chats, right? We are creating a table called chats in the sink itself. So here we are going to create a database called chats. So whatever data comes from the source, it is put into the sink, but the sink and the chats are one and the same thing. So we have configured the chats and the sink to be the same place, so that if I say select star from chats, it should straight away take from the sink through Hadoop. So my Hive session has started. Now we have to leave this Hive session running without touching anything. So let's go ahead and start beeline in a new terminal window. So here you have your new window. So now beeline will connect to Hive. So remember this in the diagram. So let me go back to the diagram. So your beeline is like your SQL interface, right? You can find your SQL interface. SQL interface to what? To Hive. Now I could have done the same thing from RStudio, but I just want to make sure the chats table is there. So let me go ahead and start beeline. So what is the command for beeline? Let's see. So it says beeline -u gdbc :hive2 / localhost 10,000. Okay. So where are we in this? So we are beeline -u. So it's difficult to see the command and do both the things at the same time. So let me gdbc :hive2 / localhost 10,000. So this should give you a query interface. So it will try to connect to Hive on this particular port number. So it's trying to connect, you see, and it has given you the prompt sign. Means once this prompt sign comes, it means you're ready to fire any query. So I can now see what all databases exist. Show databases : it shows me all the databases. So you see there are two databases, default and my database. So I will start using default database. So let's say I use default. So before that, I just want to see what database I'm connecting to. So I'll open RStudio. There is already a query over there. I just want to make sure we are referring to default database. So RStudio is starting up now. So this lab requires all the softwares to be running in order to test the data streaming. Okay, still taking time. So you see the code is already over here. So you don't have to write the code. It's there as part of the machine. The important thing is not to write the code. The important thing is to perform the data stream analysis. So I'm already firing a query called select star from default.chats. You see, so I'm referring to default database. In that I'm referring to chats table. If the chats table is not there, then you have to create it before you start the lab. So so I will use default database. In this case, I'm already using default database. You see it's connected over here. This is a command. And I'll say show me all the tables, means describe the tables in this. Sorry, show tables, I guess. So there is no tables over here. So this is a good thing. So now I can show you how to create the chats table. Where this chats table will be linked to Hadoop, and you can see that also. So how do we do that? So you need so what we need actually is we need a queries over here. So let me go ahead and paste that query. So actually this is the tweets query, but you need to modify it for to represent chats. So let's say we don't want to delete the records, so this is not what we want to do. And we want to do show tables, right? In case chats table does not exist, then use the below query to create the chats table. And what is the query? Query is this. So the query should be chats table. So I'm saying create table stats. So now remember, this is a external table, which means it is not going to create inside your Hive. It is going to create outside, and where it is going to create it, the location is HDFS, and this is the same place where we are going to create a sink. So the sink and the table both are in the same place. This is the HDFS sink as well as the location for chat. So whatever comes in this HDFS location will be picked up from chat, and we want two columns in this only. Question, which is of string type, so we don't want to put capitals, and second is answer, because in this format we are going to send a chats inside the source. So this is how your table should, this is a kind of query that you should fire in case your chats table is not there. So let's start firing the, write the query. Create external table chats, right? How does it go now? Open bracket, right? So you can press enter, so it will not fire the query until you press semicolon. So what is your next line? Says question string comma enter, answer string no comma close bracket enter. And the query is not yet over, so we are saying row format is delimited, means so we'll be sending the data in delimited format. Delimited, okay. And then after that it's space, and what it is delimited? Fields, every field or whatever the delimiter is terminated by a tab key. And where it is stored? It is stored as text file. We are saying in what format? It is stored as text file. And where is the location where it will be stored as text file? It will be inside the HDFS, right? Location HDFS : / localhost : 9000. Is that correct? Localhost : 9000 /user /flume /chats. So now before we put a semicolon, I just want to make sure everything is correct. Create external table chats, question answer, row format delimited, fields terminated by /tab, stored as text file, location. Okay, there's a spelling mistake over here, so good, I waited. HDFS localhost semicolon, then apostrophe and semicolon. So before I press enter key, just want to make sure everything is good. So there is a apostrophe missing over here, and I should be able to create a table. So it seems like now when I say show tables, I should see my tables. So you see chats is there, and if I say describe chats semicolon, should ideally say the column name, data type, and so forth. So your chats table is ready now. Your Hadoop is running. So in the diagram, so let's go back to the diagram and say, so your what all is running over here. So here you have started Hadoop, right? We have started Hive, right? You have created a table called chats, right? So what is your next thing? And ours today started, but we have not yet executed anything so far, but we have to start Flume now. And what is the command? So Flume command is little long, and can I copy inside? can I, instead of so the Flume command, while this starts, so you see the next command is Flume command over here. Flume ng agent, Flume home, conf file. So in this, the main file is your example2.conf, which will specify what is the source, what is your channel, and what is your sink. So we can have a look at it once. Where do we, where. Okay. Sorry, and here we have the browser. So let's see, we can access the file from inside the machine itself. bit.ly/tcu student, and you should be able to access your lab over here so that we can straight away copy the commands. But before we execute the command, we just want to look at the Flume configuration, the example2.conf file which it is referring to. So in BDA we get into labs, and we select BDA lab journal. So BDA lab journal is a sleek version of your lab. As I told you, the other files have more details, so you don't want to include that in your journal unnecessarily. It will be a very big file. So now what we do is we try to get that Flume command. So here you have a Flume command. I'll try to copy it from here to save time. But before I execute, I will explain you the command. So here actually we have done with the beeline part. We don't need the beeline anymore, but we'll just go with a new window now. So let everything keep running in the background. And we paste the command. Now we have to remember that the command has to be on single line. So it is there to format it, and we have missed one character of copying one. So this is Flume underscore agent, whatever. And this is the main configuration file. Sorry. Your example2.conf. So I'll click backspace over here and it gets on the single line. So now the command looks good. But before we do that, we want to look at example2.conf. So where is the example2.conf? It is in Flume directory. So let's go to the Flume directory once and look at what we have over there. So this is your Flume directory, Apache Flume 1.1.11.0, right? And we open that. In there is a conf directory. Inside there is example2.conf. So you can create many source channels and sinks using multiple configuration file. So you can have multiple Flumes, doing data streaming. So right now we are just doing one data stream. So I opened this file. So here you see you're basically mentioning what are your sources, channels, and sink. So I've given the name called chatbot data set. Now, but the thing is, chatbot data set, will pick up the data from which location. So it says tail of this command. It will read from dialogues.txt, which lies in data stream analysis. So whatever data is in dialogues.txt will be picked up, is a source where the data is picked up from, and where the channel is memory over here. You can see that, right? Channel is memory. And where is the sink? Sink is HDFS location, localhost user Flume chats. And remember, we created the table pointing to the same location. So the Flume sink location and your Hadoop, your Hive Hadoop tables are also pointing to the same location. So whatever data Flume picks up from dialogs.txt, it will put it in the sink, and whatever data is in the sink, we can use the query to fire, and this is how we'll test. So now that you've understood this, we'll look at dialogs.txt. Actually I want to start Flume first. So I go ahead and start Flume using this command, and this should start my Flume. So once this Flume is running, it is ready to pick up the text. So let's wait a little bit, few seconds, to make sure things are running. So this looks good, so let it keep it running. Okay, this is like your clock, it keeps running. And as we seen in the diagram before, right, what did we see? We have started almost everything, and now we have started Flume also. Now the thing is, all that we have to give is put something in the data source, which is your dialogs.txt. Automatically this data will go in the sink, and this data will all the way travel, we can access through RStudio. So let's have a look at what do we look. So the files and data stream analysis, I created a separate folder. So in this, you see there is a chat database.txt, which is a very big chat data set. I bought it, I just downloaded, so just to simulate as if somebody is chatting, but this is not the source. Remember, the source is dialogs.txt. So here you see there is already some text, and in the past somebody must have processed this. So let's see in RStudio what is there in the chats database as of now. So see the way this RStudio, this code has been written in R is we have used ODBC to make a connection to Hive database. So I've created a connection called HiveDB, and I use ODBC connect to it, and then I fire a SQL query directly select star from default.chats. So, and we print it, we close the connection and we print it. So if I run this, so let me close this and run over here. So you see that it's trying to run. I selected all the commands properly, and now it will run, and it will try to print chats, whatever is there in the chats. So everything is running, then your chats should show up. Actually you can, so chats has showed up actually. If you look at Hive in the background, it kind of, where is the Hive? So here you see no stats for default chats, column question comma answer, table not found default.tables. I don't know why it's saying default.tables, but my query did run, but Hive was running in the background. And here you see already there's some data, chats.question, I'm doing well, and so forth. Now the real test begins. I will send some stream data. So I'll take, so this is already open over here. So I'll take some data, and as if I'm chatting. So let's assume I was chatting, or I commented on something. There's something wrong with my right hand tab. What's wrong with it? So this is like question and answer. What's wrong with it? Again, tab, question, space, not space, tab, takes most of the time. So let's say somebody commented this, and I used Instagram to connect to it, or I used Facebook, whatever, and I put it in my dialogs.txt. I transferred whatever the comments are in the entire world. So I take all the comments and put it over here. So let me save this file. The moment I save, your Flume is already running, right? So as we seen in the diagram, Flume is already running. So automatically, logically it should go into the chats, and automatically it should show up in RStudio. So did it run? So let me test. So I put so what does the dialogs.txt have at this moment? there's something wrong with my right hand, and so forth, so forth, right? So we'll go in our studio, we'll go back again, and we'll run again. So as we run again, let's see if we can get a glimpse. See, no stats, default or chats, columns, question, answer. So it is converting your query into MapReduce job, and that's how it is able to, get to your HDFS data. So once I get the result, I should have the output over here. So has it come? So you see my data has come. There's something wrong with my right hand. What's wrong with it? So now you can actually fire any queries. I could say select count star, something like that, or search for so and so text in the chat, find me what is trending, who is trending, is this news fake, is this a hit comment. You can do all type of analysis over here in our studio. So that's how your entire lab, so this is your proof of data stream that you did using Flume, and then it went into Hadoop, and which is a big data source over there, and from there your RStudio connected to the big data system. So in case if you are going for a job, then you can explain this architecture as to how real-time data streaming works, and if you have done this lab, you can explain how this lab works. You can mention that you use Flume for data streaming, and then the data was put in the source, it went into the sink, and then the sink was connected to Hadoop. Hadoop is a big data source, it can manage petabytes of data, so it can manage the data of all the world, and you can use as many machines and so forth. And you can use a simple Hive query to analyze this data, and you can use RStudio to do the analysis. So your architecture has a Flume, Hadoop, Hive, and RStudio. So that's all for the lab. I hope it was useful. So all the best to perform this lab. So if you want your machines, as I told you, download it from the source, from GitHub, I mean. Thank you.